Let's take a look at this integral. In order to integrate this, I've tried many things and failed before I thought of a good idea. I tried a u substitution, and I tried u equals x plus 1. Didn't work very well. And eventually I got around to realizing that I could integrate this thing by breaking it up into multiple fractions. And for that I used integration by parts. So I took the integrand, the thing in the integral, and I realized that the denominator had a linear factor to a power. So I performed all the partial fractions. Please hit pause if you want to analyze all of the algebra. And after completing the partial fractions decomposition process and finding the values of my unknowns, a, b, and c, I then knew that the single fraction could be decomposed, in other words, rewritten as a sum of multiple fractions. If this seems really confusing and strange to you, you might have missed the second video in my video series inside this lesson, and if that's the case, you want to check that out. If you're not one of my Math 122 students, then you can just check out partial fractions decomposition videos. But nonetheless, the point of this mini video is to show how I can use the partial fractions decomposition to integrate. And the big picture here, putting aside all the algebraic details, is that if these two fractions expressions on the right are equivalent, then I can replace the integral of one with the integral of the other. And now, because I've expressed it as a sum, I can integrate each of these separately. And in doing so, I can quickly arrive at an answer. A quick reminder, the first integral, in fact, I should say all three of these integrals were done by a u substitution of u equals x plus 1. I didn't show any of the work here, but if you perform those integrals individually, you'll easily see where this answer comes from.